Knowing that the human resistance is basically a hacktivist level group, they likely ran some of the run-of-the-mill web application testing tools against your GlobalMantic's website. I'm going to cover ways to incorporate some of those same capabilities into your detection so you can get ahead of the game in later modules, but that also means that they likely have found other input fields to test for other types of injection. Still well within the injection category, the next exploit methodology to cover is SQL injection. This is similar to command injection at face value, but really deals with a whole different system that is common to almost every web application in existence. Databases are the back-end information store that handles the storage, manipulation, and transaction of the data that the application is concerned with. SQL query language is the language used to commit, read, or manipulate information to a SQL database. Some of the options for user input in a web app check that user input against a SQL database, and this is where the attackers can come up with a specifically crafted query that will execute unintended queries or activities on the back-end application database. It works like this. A malicious user will attempt to submit a query into a user ID field that will equate to true, and then add the user's password to the user value that's supposed to be returned. This is not executed by the web server or any back-end code located in the web application, but instead, it is passed from the web server to the database. The database then executes that query, assuming the payload works, and returns the result. In this case, the username concatenated with the user's password, and the web server serves up the response to the user. Now, this malicious user has the password to any user that can get this query to execute for, and can log into the web portal as whoever they want. So next, let's take a look at how that works in the GlobalMantic's environment on their internal web applications.